Hello and welcome back to module number 5. Today we're going to talk about mathematical formulas and how can it be applied to R and what do we do with that in R. But before we will move towards mathematical formulas and how to compile them in R, I need to start talking about your final project because some of you already asked me about that. The idea of the project is that you're going to collect some data, trying to facilitate and be able to generate your own calculation on that data, and you're going to compile it into a package that you will be able to share with other people, and people will be able to see what you have done. Um, I'd like to show you example. The links example is an example of people that started a project like that in R, and they often use that in as a part of a conference or part of idea of what it entails. And the idea is that you come up with the idea and how the R can help you to match the objective of your project in order for it to fit. And so you're going to search for data, search for area that of interest to you. I will be happy to be your help to sort this out. Um, but it is up to you to decide what is your data that you like, you have passion to, and what type of statistical analysis do you want to apply in order for you to build such packages, because the majority nowadays is already exist, but I want you to have your own unique contribution to open source R. So those are the example. Just take a look at them and see if it make more sense. Okay, so today we're going to start in today's module. We are going to talk about a little bit review of what we have discussed. We are going to talk about different type of data and how can it be applied, and we are going to talk about single variable, two variable, and three variable. We are going to also talk about random data, how we generate random data in R, and how can we apply statistical analysis to it. And we are going to talk about mathematical functions, how to sort mathematical functions, and if we will have time, we will talk about linear algebra and vector and matrix in that context, how to apply the linear algebra operators in order for us to sort the data. So the framework itself is about the data, but in practice, we are going to look at different mathematical formula. So last time we talked about data frame, and the objective in my side was that you will learn about this data structure. Uh, this type of data structure is not a commonplace as we are accustomed to see in Excel or SPSS. And the idea here is that data structure in R is really important, because you will see as we experience more and more R packages that use the data structure differently. Some of them use data frame as the main component or the structure of how the package is being analyzed or the formula is being analyzed. Some of them use vector and matrix. So I want you to have a solid understanding on those terms in order for you to do that. Then we started to talk about a little bit about statistical measurements, and we did not talk, and this is something that in the end of next module we are going to talk about validation and the idea of how to conduct validation using R, and what is the instrument and the method to measure the data to be able to report that your data is valid and accurate. The idea of validation, to those who are not familiar with this concept, is that in every type of analysis, one of the things that require of us is to validate our analysis. Can we is someone else can take your code and take your data, will come up with the same result. Validation is essential to our progress in order for us to make progress. And without the validation, we need to make sure that the tool that we are using is accessible to everyone, but also the code and the data that we are using. And this is really important for me with regard to validation and to validate our statistical analysis. So back to our subject, and we talked about we need to talk about different types of data to address different type of statistical analysis. We need to talk about one variable, two variable, or more than three variables. Those type of variables has a name and have a purpose, and in that case, each type of statistical analysis usually consists of different analysis than the other. Example, bivariate is not only descriptive statistic because we can compare two variables and make predictions about it, compared to single variable that we are talking about a one person, a place, or a thing, and that is comparison to multivariable that use multiple variables in order for you to do that. So we also need to match up again with regard to the type of measurement scale. Is it categorical or is it ordinal? Categorical, also known as nominal, is usually classification of people, places, of things. Ordinal is the idea of classification of people, places. Example, poor, good, and excellent is a good example of ordinal or ranking scale in order for us to measure or to come up with analysis based on it. We also have interval scale, which is data classified by ranking. And the idea here is that, again, there is a 0 point of scale in order for us to evaluate. However, and again, this is however, the issue is if you find data, example, data that you collected from Twitter, or data that you collected from the federal government or the state, how do you have the ability to measure its scale? And this is something that we will talk throughout the semester. What do we do? How do we apply that? And again, the other scale or the other method is the ratio. And again, usually idea of scale the data in order for us to do that. So let's start our conversation with regard to single variable, where we are observing one aspect, something that at time. With a single variable, we can put all the observation into a list of numbers. And so the idea here is that we can use descriptive statistics such as the average, or the mean, or the mode, or the standard deviation, and we will display it by histogram or normal distribution. I just want to make a point here. I am very passionate about visualization. Why? I'm a visual person. And so when some of you ask me, why do I need to do this visualization? For me, this is the essence, or you know how to understand the R, and this is how I treat that. So this is my little 2 seconds note about why is it so important to visualize or to apply the visualization capabilities that R provide us. Distribution. In descriptive statistic, we usually provide the idea of distribution, and we are applying that in that sense to understand how the distribution of a single variable can be applied. The one of the basic techniques of descriptive statistics allowed us to do is talk about range. Range is the difference between the minimum and the maximum value in the data set. And in this case, we create a container with all the data, and we will say range, and we will open the container in order for us to apply to it. The idea of single variable in R is also the idea with regard to the mean is also part of the example, and in this case the code for the mean is very simple: mean and the container that we want to apply to it in order for us to do that. So again, it's a review, my notes on the review on the mean, what does it stands for, what are we calculating in the mean. And so we can calculate the mean and the median. And again, the R in code is really simple in order for us to understand that. But we can also use the idea of make it a more code-oriented language in order for us to allow us to give more a calculation into the idea. In this case, first mode, I wrote a function called v, and I applied the v as a container in order for me to show you the result. And in this result, this is what it looks like. So again, the idea of what can we take from the data in order for us to come up with a result that is unique or interesting to learn about the data itself. The variance in R is the variance with a container, as I showed you in the below, and the standard deviation, again, the same type of it stands for the CD, and you calculate the standard deviation. So again, this is how we sketch the distribution. This is how we operate, and in this case, we can use the code histogram in order for us to generate a simple histogram without any color, without any feelings, without any a lot of visual, in order for us to tell a story about the data. One of the things that we always need to talk about is probability distribution. Usually, probability distribution is a table or equation with a link of the outcome statistical experiment. And usually the variable has some structure or common symbol that we all understand. So in this case, the R also provide us with the idea of distribution. And we have normal distribution, and we have more advanced distribution. And the idea of normal distribution is that we will see the curve of the data. So the idea here is that the prefix of D to the function, you can get the probability density values, and in this case is PDF, in order for us to have the probability density values. The textbook talk about that. I just want to make sure that you will understand that, and because we're going to go into that in depth about distribution and about the probability. Another issue that is really important is random number. I don't know how long since you took your statistics class, but if you remember, random number is a variable that assumes numerical value associated with random outcome of the experiment. So it is the numerical value that is assigned to each sample point. So the idea here, we have two types: discrete random variable and how it looks like. And we also have, sorry about that, and we have continuous random variable. In discrete random variable, we are talking about experiment, make 100 cells call, and we have the random variable called random variable is called a number of cells, and we have possible outcome. And this is what it will probably look like. Continuous is the idea it's unlimited, it's uncountable. So we have a lot of options in that it is weight of 100 people and there is no scale on it. Or the measure part of life, hours, how many hours people experience in life. And so again, this is continuous random variable. And again, this is something that we often use. So discrete probability distribution of a random number is it's often used in order for us to illustrate the idea of probability. So the px is smaller than 0 to all values of x, and if it will be equal, whether the assumption of the value of x, in this case, in discrete probability, we will have more accurate reading on it. So if the value of x, we will know that it is equal to 0.25. If it's 1, we will know it's equal to 50. And the visual display of it in this case is how we apply to the formula in order for us to do that. So again, the summary expected value of the mean of the probability, the weight average of all possible values, and the formula that we apply to it. The variance, again, the issue of the weight average of the square definition about the mean in order for us to apply that, and the standard deviation. So let's start with the R and how R treat that in that sense. So one of the things that we have different type of distribution, and we have binomial nominal students test, uninformed. All those are functions in R. An example is destiny estimating probability distribution, and it's the idea that you will be able to have that with a slide, the ability to build about probability of 20 distribution that including the following tables. And in histogram, it will show something like that. So we will be able to display the destiny probability of that data. So again, the idea of the beans, the number of beans in this case, and the breaks in order for us to display this type of distribution. And we can also influence the curve over the histogram in order for us to show that. And this is again the beauty of R and the power of R with regard to distribution. We know about the distribution, we can illustrate that. But the curve is something that the R allowed us to show. Why is this can be curved into a normal distribution, or maybe it's not. And this is the formula that we often use in order for us to apply. So again, destiny curve over histogram, and this is the idea. Next is the idea of two variable bivariate analysis. And in this case, we are using not only descriptive statistic, we can move on to a little bit more advanced statistic analysis. Example, suppose a student survey is done to evaluate if students who smoke study less. And this is the data that we have, and the amount of studying and the amount smokes and the person. And so in R is very simple. We have a container that who are the smokers, the amount of smokes, and we can create a table with the smoke and the amount, and we will give us the idea what is it consist of. The examination of the relationship between smoke and grade can be applied to a table. An idea here is that we can store everything under a table in order for us to calculate what is it entail. And so in this case, we can apply the idea of relationship into, again, as I told you, I am a very visual person, bar plot of the table amount versus smokers, and we can see the outcome. The issue that we need to think about is the categorical versus numerical. Suppose you have numerical data for several categories. And so we have experiment and we have a control. And if we will display it, it will look something like that in a box plot. Another way for us to visualize the result. And again, this is where we are going to start seeing that how the visualization help us to sort the data, to understand the data with regard to its value. The last aspect of our review is with regard to 3 variable or more or multivariate analysis. And the idea here is that we are trying to, the observation can be used as a matrix form, and we can generate based on weight, height, gender study, something that you already apply in your assignment. And in this case, we can sort it as a table in order for us to do that. So we can use the idea of stack and unstack in the idea of the data frame in order for us to sort the data. And again, this is a way for us to understand what is the data stand for, and again, how to apply it. Again, I recommend you to use this example to illustrate for you the idea between stack and unstack in data frame and how to apply that. And I gave an example of how to apply that in my PowerPoint as I go across, but this is the idea of what is the power of data frame and what is the power of R with regard to sorting the data and to ability to do that. One of the things that we will encounter endlessly throughout the semester is that using R for notation. And the model formula notation in R allowed us to be done in a systematic manner. So let's take example box plot, and we will say the weight versus the group. So the idea in this case, we are going to look at 2 responses of a variable, left side and the right side, when we have 2 variables. And here's the table that will show you 3 variables, x and y, and again, idea to capture the idea of how to capture in a simple model that will allow you to develop a module that will be better fit into your data as we go along if you will need that. R has a very comprehensive library of function to generate a random number. So in this module, I will focus only on the simple form is how to generate a random number. So in order for you to generate a random number, you're going to use the function called RIF. And in this case, you're going to specify to the R the premises of your idea and what does it entail. So in this case, I'm going to generate one random number between 2 and 10. And so I lay out in my code that I want one number between the number of 2 and 10 in order for me to generate, in this case, it's going to be 8.378. This can change every time I will run the R, but this is the idea of random number in R, and this is where we're going to do that again and again in order for you to see how could you generate. So again, example of R, how to generate integer between 1 and 10 and how to apply that. This is my general review on basic probability and a basic idea of random numbers. Now I want to start the idea of mathematical functions and the idea what is it entails, and I will try to slow down the pace here because this is a little bit more difficult as I experienced teaching the class for the last 3 years. This is where students get confused, so I highly recommend that you will consult with a textbook in order for you to understand what it entail. I lay out for you the following functions and what does it entail in order for us to start. Okay, so we will start with matrix algebra. And the definition of matrix algebra is n multiplied by m matrix, that in this case we have idea of elements that is consist of. So in this case, n is equal to the number of columns, m is equal to the number of rows, and the dimension of this matrix is n multiplied by m. In comparison to what we talked about in the beginning about the vector and the role of the vector in data set, in mathematical premises, the vector is a dimension of n, and usually it's n multiplied by one matrix in order for us to sort it out. So the vectors will be column vector that will be also row vectors into it. So the vector v in this case is a dimension that can be thought as a point of dimensional space in order for us to capture that. And this is an example of that dimension. Now back to mathematics, and now we're going to talk about the idea of adding or addition into the mathematical matrix. And in this case, the layout is the dimension of A and B are required to be n multiplied by b. So in this case, this is the formula that I'm using, a plus b, and it will be equal the a with the container plus b, which will give me all those dimensions with regard to the values. Secular multiplication in this case is the idea of that C can be any secular. So CA is the matrix. In this case, it will represent the issue what it will stand for. And in visual representation, the vector will represent the following points in order for us to do that. So multiplication in a vector, this is the outcome. And the matrix multiplication, this is the product of A and B as denoted by A multiplied by B, and this is the formula that we will use. So in this case, A is the n multiplied by m matrix, and where the m multiplied by one vector, and then what it will entail. The definition in this case of n multiplied by n identify the matrix and what is the sequence of the matrix itself. So the definition of the inverse matrix and what does it entail with regard to the matrix itself. And that's all for now. I will continue this discussion next time. Go back to the textbook, see what it entails. I will give you a very short exercise on mathematics, and I hope you will understand, because I'm sure that in the last slide none of you understood what I'm saying, and maybe the assignment will give you more aside or help with that regard. So until next time, I hope you will enjoy that, and I will see you next time. Bye. Whew.